And let's dive right in. So I'm, as Steve said, Albert Breyer. I'm the Director of Project Controls for Dokainish and Company. Dokainish and Company is a project controls and system implementation contractor based in Toronto, in Ontario, Canada. We are heavily involved in the nuclear industry here in Canada, but we also work in a variety of other industries, including pretty much anything you could name, all the way from fashion to infrastructure. And one of the services that we bring to most, if not all, of our clients in some form or another is risk management. Now, as Steve mentioned, I've got quite a few years in the project controls salt mines, and a big chunk of that was spent on risk analysis, risk assessment, risk management. And I've been using quantitative risk assessment tools like Safran Risk for a very long time. In the relatively early days of Safran Risk, I pivoted over because it was pretty clear that it was, one of the better simulation engines available at the time. And in the time that I've spent using it, it has matured from being among the best to easily the best. And part of the reason why it's the best is because it enables some really advanced visualizations and analyses of risk inputs and outputs. And the reason why we developed Dokainish Project Risk is because we knew that we could squeeze more utility out of that very excellent data that Safran Risk generates for us. So let's dive right in. Now, first off, what you might be noticing is that you're looking at a landing page which has helpfully labeled itself somewhere as Power BI. So this is, in fact, a Power BI dashboard. So you might be thinking, well, what's so special about that? I will show you. When you click through from the Dokainish Project Risk landing page, you wind up here on this candy-colored help screen. And I won't spend too much time here because we're going to click through pretty much everything on the navigation bar. But this does highlight one of the key features of Dokainish Project Risk and one of the things that differentiates it from just having a Safran Risk license and opening it and running the models. Okay, like the big difference between using Dokainish Project Risk and using Safran Risk is that the Dokainish Project Risk tool is intended for everybody on the project team. Safran Risk is remarkably easy to use. It has a great interface. It's clicking through the visualizations is simple, straightforward, intuitive, but you do need a license, and the software does have to be open. Once the data model has been baked in Power BI, we can give those very same capabilities to everybody on the project team. Now, the reason why we've got this screen and screens like it is because we want people who have very minimal or possibly even no training in risk analysis to be able to come into this tool and get something out of it. There's a lot of explanation and guidance built right into the tool itself, and it starts here. So the very first thing people see when they click through, before they even get to their results, is this explainer page telling you what every single thing on the navigation bar does, and my personal favorite thing, the slicer panel, which we'll get to in quite a bit of detail later. So let's continue to the results. So what you're going to see today are the results from a real risk analysis that we ran a few years ago. The actual identifying information and the numbers have all been randomized and changed to the point where we are dealing with a fictional project at this point, but this is the outputs of a real analysis. Now, in any real analysis, the main output is going to be a risk report of some kind. Generally speaking, those reports are very, very large, right? Like they have a lot of information about the project itself. They have a lot of information about how the model was set up. If you're doing an integrated cost and schedule Monte Carlo simulation, then there's a lot of information to say about how the model was set up. You have to get into how the integration was accomplished, where the model seed was set, whether you use hypercube sampling or something similar to economize on your calculations. Like that kind of thing is all here on this front page. And we also provide a link to all of those reports, files, and additional details right here on this page. So the idea here is that when Dokainish and Company delivers a quantitative risk analysis, we deliver the traditional reports that you would expect to see, and we also deliver this dashboard for the reason that this dashboard supplements and helps to explain all of those outputs, and in addition can replace and even augment them in some ways. So you start here. It gives you all the information you could possibly want about the project and the model setup. And if you need even more, then there's a link to get to it right here. But that's not really the fun stuff. The really fun stuff comes in here where we've got the live results. So I've just clicked this dashboard entry right here in the navigation bar. And you can see some of the more common risk output results that you'd expect to see from a Monte Carlo simulation showing up on our Power BI dashboard all together. And you may notice that it loaded in rather speedily. But by the same token, if it's just static data, that's not all that impressive. The thing is, it's not. So if I click this chart settings panel, I'm exposing a lot of slicers that I can apply to these data. And these slicers are durable slicers, okay? So one of the things that makes Safran Risk so powerful is that when you have the model run and you've got the software open and you're tooling around in the inputs, you can change a lot of things about how the inputs are shown. You can change focus activities, you can change p-values, you can compare results to each other. But that does require you to be in the software, and it requires you to have everything pretty much already done on the back end. Well, once you've got those results, we're now allowing people who don't have a Safran Risk license, who may be part of, say, the field construction team or the project management team who aren't risk managers themselves, to come in here and change the focus activities. So our anonymized project here is a mine development project. This one is set in Australia. So if we wanted to, we could say, all right, I've got the current slicer set up to show results for the entire project, okay, which what we're calling here mineral mine. So, but in fact, the project is broken into two phases: an advanced exploration phase where they're doing, drilling a test tunnel and figuring out how much ore they've actually got down there, and then a full construction phase where they're sinking the full mine shaft, doing all of the developments, and then producing ore. So let's see just the advanced exploration phase and see what that does. So I'm going to close this slicer panel here. And you can see up here in the top, the title bar has changed. You can see down here, all of the visualizations are changing because we're now seeing a set of results that are specific to the advanced exploration phase of this mine project. Furthermore, you can see we've got all of the normal outputs you'd expect, including one advanced one that I'll spend quite a lot of time on, that being the joint confidence level scatter plot. But everything else that you would expect to see at in a risk output report is right here on the dashboard. So I mentioned earlier confidence intervals. I like having my lower P at 50%, but maybe my client is looking for a slightly higher confidence at their low end. So I'm going to bump that up to 60. And then I'm going to say, okay, if we've got 60, 75 doesn't give us a lot of room to play with. So let's say that we're setting our upper confidence interval at 90. So I've just changed lower P to 60, upper P to 90, and I'm going to change the number of risks from 25 to 10. And that'll change all of the elements of the dashboard in real time. As you can see, it kind of churning on that in the background there. Now, one of the questions I often get when I'm demoing this tool is, do you have Safran running? Like, is it pulling from the Safran? I don't, right? This is what we call our baked data model, driven by the very excellent and high quality data that Safran makes available to end users through its export features. So in most of the tabs in the outputs in Safran Risk, you can export data, and it usually will give you a big chunky spreadsheet, right? So those big chunky spreadsheets, what we have done is we've integrated those into a data model on the back end of this tool that enables live slicing and changing of confidence intervals, focus activities, as you have seen. The other nice thing that it does, well, two nice things, like I mentioned, it democratizes the tool by putting all these things into Power BI. Basically, everybody with a computer and an internet connection can get to Power BI. So we will host these on a SharePoint site that is provided directly to the project team that requested the risk analysis. And everybody who is invited, onto that SharePoint site can click through this thing and figure out exactly what it is they want to see. And the second thing that I really love about this is that we built this with executive presentations in mind. Okay, so one of the things that I want to touch on in some detail is that we all know that a quantitative risk analysis, like a Monte Carlo simulation study and the risk outputs like the one you're seeing here, their primary use case is to be put into a PowerPoint slide deck and used to justify, say, a funding request. Well, you'll notice that all the navigation stuff and all the Power BI stuff is pushed out to the edges. We've got our own logo down here at the bottom, but we can put the project's logo, we can put the company's logo, we can put anything you want. We can customize what the titles say. And then when you're ready to build your PowerPoint slides, you come into Dokainish Project Risk, you set all the slicers the way that you want them to be set, and then you just snip it, copy paste into your PowerPoint slide deck, job done. So in addition to being a democratization of those quantitative risk outputs, it's also a way to simplify the use of those outputs for its most common use case, that being executive stuff, So another thing I want to point out about this dashboard is that it is durable. Okay, so I made some selections here in the slicer panel, like I'm looking at advanced exploration at a lower P of 60 and an upper P of 90. So those settings will persist throughout the dashboard. So to demonstrate that, I'm going to jump straight to our finished state cumulative frequency graph. So this should look very familiar to anybody who has seen a risk output report before. It's your lovely histogram and cumulative frequency curve. Now this one, as you'll notice up at the top here, it is advanced exploration showing a finish date, lower P60, upper P90. Those are the settings I chose earlier. So everywhere you go in this tool, those settings will be durable. So if you want to create that PowerPoint slide deck that I was talking about earlier, then all you have to do is set the settings once and then click through all of the elements of the navigation bar, take your screen grabs, throw them into PowerPoint. So we built this with efficiency and the end user in mind. But the real magic here is the ability to mess with these data live, as I did on the dashboard. Now, the dashboard was showing 6 different visualizations. So compared to the rest of this tool, it was a little bit slow. But I wanted to show you just how quick this thing is when you're doing it not in the dashboard, but in one of the specific visualizations. So I'm going to very quickly switch from advanced exploration to the full project. I am then going to change the lower P back to 50, and I'm going to change the upper P to 80. And because there's a lot more results, you can see the histogram is looking a little crowded. I'm going to change that from week to month to give me a little bit of space to breathe. And as I was saying all of those things, it's already done. So as speedy and user-friendly as Safran Risk is, this is faster. So, and largely because Safran Risk is doing all the heavy lifting of actually doing the math, right? And this has the benefit of having already consumed all of that math. There's only a few calculations that this tool is doing independently of Safran Risk. But the main thing here is that you've got a pre-baked data model from which the tool can simply pull, as opposed to having to recalculate outputs when you change things like the focus activities or the confidence intervals. So you'll notice over here a stats table, which should be familiar to anybody who's seen a risk output report before. But these are a lot of things that you would actually draw your results from. Like, for example, the lower P value, which is our P50, is telling you what the finish date is at that confidence interval. It's telling you what the upper P value is. It gives you the deterministic date. Now, because we run a stripped adjusted base estimate model, we don't expect the finish dates or the costs to actually have a particularly high confidence interval, okay? And one of the things that we're working on is integrating targets into this dashboard all across the board. Now, we do have them in one place, which I'm very excited to show you later. But for now, you can see that the deterministic here is sitting at a very, very, very low confidence interval. Like, there's the deterministic bar right at the bottom at 0%. But just like in Safran Risk, you can see that the 50%, it drives across, and there's a very nice, clean 90-degree, comes right to the curve. So these are good, clean outputs that very closely mirror what you would find in the tool itself. Something else that I love about this tool. Also in the stats table right here at the bottom, you're seeing measurements for skewness and kurtosis. So what are skewness and kurtosis? Well, if you're not a risk manager, like if you're not cracking open academic articles on Monte Carlo simulation in your spare time, then you may not have fully internalized the definitions of skewness and kurtosis, and I think you can be forgiven for that. But what I will do is show you this. When you click any of the headers in Dokainish Project Risk, they're not just there to organize the actual clickable elements. They are clickable elements. Why? Because they contain all of this information. So I mentioned earlier that this was designed to democratize risk outputs and provide as much information to rank and file project team members as you could really possibly want to help them understand what they're seeing when they're looking at something like a histogram with a cumulative frequency curve. So we've got a nice explainer showing, basically what this thing is doing. It tells you all of the elements in the stats table, where they are deriving their results from and what they mean. And as I mentioned earlier, skewness and kurtosis, slightly wonky elements for anybody who's not a professional risk manager. But here is an explanation of what skewness and kurtosis mean and what they practically indicate when you see them on a cumulative frequency or a histogram distribution. So we're pretty proud of this. There is a lot of explanation about how these risk output visualizations are functioning and the numbers that they're showing. So anybody with access to the tool can be relatively self-sufficient. Like if you are a professional risk manager, and I imagine many of you in the audience today are professional risk managers, you've probably had, now I'm about to make an analogy or give you an example that's going to make me sound old. But hey, whatever, here we go. You've probably had the experience of sitting at your desk, minding your own business, doing your own work, and having somebody wander up with a cup of coffee and lean on the cubicle wall and say, hey, Albert, well, maybe your name's not Albert, but if it is, then they'll say, hey, Albert, I didn't really understand what you sent me. Can you explain this thing to me? What am I looking at here? And then you got to turn your monitor around or drag them into a meeting room and, pull everything up and whatnot. And that might be a very positive interaction for the both of you, but it also might be a real drain on your time. So a lot of those questions can be answered using a tool like Dokainish Project Risk that has a lot of the more I would call them the basic answers to those questions right here for you, ready to go. So I would be remiss if I didn't click through some of the other options under cumulative frequency. Obviously, we have a duration-based view as well, which for the full project is going to look exactly the same as the finish date results. But it's worth noting here that we can do some kind of fancy stuff here. I mentioned that a lot of this is designed around presentation and delivering a high quality presentation to stakeholders. So if we want to go for, say, the second phase, the full construction phase, that's where you're going to start to see some differences between the finish date and the duration-based view of things. You'll also notice here there's a button called histogram auto sizing. So I'm going to click that button. So what you'll notice is that it took the option for me to size the histogram bars away, and it automatically sized them to make for a nice clean presentation, right? Now, if I don't like the way that this did that, I can simply switch it back and pick my own. So if I want it to be quarters, there's quarters. And that was approximately what the auto sizing did. Perhaps I want it to be somewhere in the middle. Perhaps I want it to be months. Now, I personally like a nice thin histogram bar. I like to see the curve shape so that I can read the skewness and kurtosis off it. But, matter of personal preference. And that's one of the things that I love about this. Personal preference, fill your boots. You want to see months, you want to see weeks, you want to see a different part of the project, go nuts. So let's look at cost. Cost functions very much the same way as duration, as they're both, buckets of quantitative measures, like the finish date is a point in time. The cost and duration are both amounts of something, dollars or days. So I'm not going to dwell on this too much, but I just wanted to let you know here it is. Like I said, it functions very much the same way as the schedule-driven stuff, and you get a whole set of new results every time you click through and change all the filter settings. So in addition to the cumulative frequency and other such distribution stuff, you get risk correlation and sensitivity from here. Now, correlation is one of the few things that we had to, that the tool is doing, right? So the correlation was actually simpler for us to generate on the fly because the Pearson's correlation coefficient is a pretty simple mathematical formula. So we just designed Dokainish Project Risk to recreate the correlation coefficients when the tool is running. So you can get all the same stuff and it maps one-to-one to the stuff you get from Safran Risk when you have the tool open, but you get it in a slightly different looking format here. So this format is nice and tabular, everything. Oh, and look at that. There's a tooltip. So this is, for those of you that have seen this tool before, this might be new to you, okay? So I mentioned earlier that this tool is designed to be snipped into a PowerPoint presentation, and while that is true, it's primarily designed to be used live by risk managers who are doing their jobs. So if you are trying to figure out what's going on with this top risk here, the damage relationships on your indigenous benefits agreements, then you can mouse over that risk and it'll give you a nice tooltip, not just showing you stuff that you can already see on the screen, okay? This is actually digging into the risk register and giving you information from the risk register. It gives you the 3-part risk identification, the cause, the event, and the consequence. It gives you the quantitative inputs that were determined by the project team. So you can see there 14 days, 120 days, and 365 days. We have those on a triangular distribution. And you can see the same for the cost. Okay. Now below each of those for schedule and cost, you have the schedule sensitivity and cost sensitivity results from the QRA. So this is one of the benefits of having a baked data model driving a live sliceable dashboard. We can actually pull information about each of these risks into different visualizations than you would normally see those in. So, you know, to rephrase, you don't have to go to sensitivity to see the sensitivity results for this risk. Here it is. So at the lower P and the upper P. You don't have to dig into the risk register to determine what this risk is all about and how it was estimated by the project team. There it is. It's got the probability there too. So everything you need to know about the risk, you can actually get to from the correlation screen. That's really unusual. So those of you that haven't had to interact with, you know, wonky risk outputs before, you may not know that you generally do have to do an awful lot of clicking around to get access to these data. Once the risk model has run, you're generally confined to the risk tool or whatever output report you happen to be writing from the risk tool. You generally can't just see the live interactions between these things. And speaking of live interactions, one of the other things that we're really proud of are these risk cards. So this explainer is a little bit out of date. It shows an older version of the risk card format. But in general, this is what the risk cards are. They are a way for you to view the risk register in a nice visual way. In fact, let me just jump straight in. So here's our kind of version 2.0. I guess technically it's 1.3 risk cards. And you can see that it's telling you a lot of the same stuff that the tooltip was because it's all drawing from the same data source. So here we are on that. This is a different risk. This is a long lead and supply chain risk. You can see how the qualitative scores map out here onto this spider chart. And for what it's worth, I think I'll just switch to maybe something a little, there we go. There's that damage relationships risk. So let me grab that one. We'll watch it change live. And you can see the spider chart update. So we've got, different qualitative scores for the different risks. Of course, you've got a risk proximity measurement here. Everything you need to know about the risk, qualitatively speaking, is up here in the top. That stuff will be durable. It's going to stay put. And then we're going to click over to the quantitative, and you'll see all of those risk inputs that I mentioned earlier that came up in the tooltip. Here they are in greater detail. So you can see the triangular distribution estimate for schedule. It's the same 14, 120, 365 that you saw in the tooltip, but now you get to see the justification for each of those. You can see that we've used a triangular distribution. You can see how that distribution looks. You can see any commentary that the risk team had about this when they built the risk model. All of that comes right into this tool. Because quite frankly, if you're building an integrated cost and schedule risk analysis in Safran Risk, you have to do all this stuff anyway. So we've consumed all of those data to create background data for Dokainish Project Risk, so that instead of having to click around to all those different spreadsheets and different input files and different tabs in like a proprietary risk tool, it's right here in Power BI. Now, where this really shines is, and this is another new feature, some of you have seen this before, may not have seen this, those sensitivity results that you saw on the tooltip, here they are again on the risk card itself. So you can do this for any risk. So we'll grab this damage to equipment in a third party, and you'll see everything changes. So just like the rest of the dashboard, you can change the focus activity to show the sensitivities against these different elements of the project. I must have misclicked something there. My apologies. Let me get back to the QRA results. So you can see how it pertains to the different elements of the project. You can change the upper and lower Ps, and you can watch how those results react to those changes in real time. So this was one of those things that I really pounded the table at when I was talking to our developers about getting this thing done, as I was absolutely insistent. We have all these data. We need to make these things sing. So here we are doing it. I'm very proud of this element in particular because as far as I know, this is the only tool of its type that will let you view the static risk inputs and the dynamic Monte Carlo simulation outputs together in the same place. So that's our risk cards function, and I've saved the best for last here. Now, I should mention, we do, of course, have sensitivity tornado charts here. I've been showing them off through the tooltips and through the risk cards, but we have them shown in standard tornado chart format as well. And these do, I believe, also show the tooltips, or no, that's coming soon. So where I want to spend the last few minutes of my presentation here, and I want to make it clear to the extent that it hasn't been clear already, there's going to be plenty of time for questions. And I'm kind of going through this at rapid speed because I want you guys to see everything. I want you guys to get a feel for how I use it and how I expect risk managers and risk professionals to use it. But I'm very eager to hear from you guys about what you want to know more about the tool, how it interacts with Safran Risk, how you might use it on a day-to-day basis, and the ways in which it is maybe a little bit or perhaps a lot different from other tools that are superficially similar. So we're leaving lots of time for questions, but before we get there, I do want to cover off joint confidence level analysis. I want to cover it off for two reasons. One is it is useful on its own. All right. It tells risk managers what they already know, which is that you can trade cost for schedule, right? Like not all P50 results you get from a JCL are equally valid P50. Okay. Real quickly before I move on to JCL, I just got a question on the risk card. Is it synced with the spreadsheet or is it a specific risk repository tool? These came from the same input spreadsheets that you would have used to seed the model from Safran Risk. So when you are building Safran Risk as those lovely output templates, which everybody repurposes into input templates, anything that you can put into those templates is readable by Dokainish Project Risk. So that was an easy one. Thanks for that. Back to JCL. So let's just dive into it. So the JCL is a view of the scatter plot that was pioneered by NASA in the 1990s as a way of getting a better idea of what the risk profiles of their very complex and complicated projects actually look like. So like I said, every project manager worth their salt knows that you can trade cost for schedule to at least some degree, right? Like if you don't care whether the project comes in, quote unquote, on time, if you're allowed to delay it for whatever reason, then you can maybe save yourself some money. Like you don't have to do quite as much schedule compression and crashing. You maybe don't have to hotshot all of your materials to the site, that kind of thing. But it's also true that you might have the opposite, right? Maybe schedule is of prime importance. So you want to hotshot things. You want to compress the schedule. You want to crash the schedule. In those situations, a single P50 just isn't going to do it. Okay. So if you are meant on here, it's a P60. Let me change it back. Actually, I'm going to go back to 50 and 90, or 50 and 80 rather. And mostly I'm doing this just to show off a little bit. I always love messing with the confidence intervals live, especially on this visualization, because it's worth noting we run our simulations 100,000 times. So, and we haven't skimped. What you're seeing here is 100,000 dots, each of which is one simulation result. And again, that's driven by the Safran Risk export features. So Safran Risk will quite happily export your entire simulation data set. And as to my knowledge, it's the only tool that will do that in a method that is even, or in a format that is even kind of understandable by us mere humans. So you dump that data set. We have some Python scripts that clean it up and pull it into a data model for us, and that allows us to very speedily slice and dice the scatter plot outputs into their JCL bands. And that's, by the way, the other thing that Dokainish Project Risk is doing live. The JCL formula, much like the correlation coefficient formula, pretty simple algebraic math. So we just have the tool doing the math for us and coming up with the JCL bands live while I'm interacting with it. In addition to that, we have a custom tooltip setup. So right here, right before this curve runs vertical, this curve is called an isoquant. So like the curves between the two different color bands here, like between P50, this border is actually your P50. So here at the top end of the isoquant, you'll see a JCL 51% result. This is a single iterations result that finished on the 22nd of December in 2032 for a cost of $1.8 billion. And down here, a similarly valid, at the bottom of the isoquant, that's finishing 8 months later, 7 months later, at a cost of about $50 million less. So you can see that there's a lot of variability in your quote-unquote P50 results. There is a most valid P50 result, like there's one where the model kind of is concentrated most closely. But yeah, Steve has a good question here. I imagine. So how can we clearly explain why most of the times the deterministic is set at P0? Well, I can explain that in two ways. Like one, deterministic cost and schedule estimates almost never include for risk. And even if they did, in order to run this analysis in the most responsible and accurate way possible, we would take all of those risk estimates out. All right. So what you're looking at in terms of the deterministic sitting at P0 is us having taken all of the padding, all of the extra contingencies, all of the fluff out of both the cost and schedule estimates, and then simulating the project so that we can add the fluff back in a data-driven way, that is informed by our risk exposure, as opposed to just a best guess by an estimator. So we do strip everything out before we run our analyses here, and that is best practice according to the AACE, and as far as I know, basically everybody else who writes best practice for risk. But it is worth mentioning that the internal targets set by the organization are not valueless, right? Like we're saying that you're coming up with P0 for the deterministics, and that always causes a conversation with the project team, all right? Nobody wants to hear that their estimate that they worked for 2 weeks on, did a whole bunch of QA on, the best data in the industry has gone into this estimate, and it's P0. Okay, well, what do you know that I don't, Mr. Risk Manager? Maybe nothing, but I do know that if you take all of the extra stuff out, you're going to wind up pretty close to zero, if not exactly at it. But that doesn't mean that that's your target. Okay, so if the estimator put a lot of thought into how much cost they think the cost, or how much money they think the project is going to cost, then we should respect that, and we have a tool for doing that. So down lower in the JCL menu here, we have what I like to call our targeting system. All right. So let's assume that we're approving this project at P50. So I'm going to turn the upper P off, and that will eventually kill one of the bands here, or one of the crosshairs. There we go. So now we're left with 2 crosshairs. All right. And this brings me to the second reason why it's important to show your JCL results to your clients. This, by the way, is some free advice for those of you out here running integrated cost and schedule risk models, but not presenting the JCL as your primary outputs, let me tell you why you need to start. So you can see right here the asymptotes of the kind of quasi-hyperbolic curve that is our isoquant at P50. These asymptote values are where they're where the project P50 is bounded, okay? So on the schedule side, you can see this P50 is bounded here. And on the cost side, you can see that it's bounded here. If we had more time, I would ask the audience to guess what exactly those bounding lines are. But in the interest of time and in allowing for more questions, I will simply tell you, these are the P50 results, okay, from the cumulative frequency distributions. So when you read your P50 off that cumulative frequency curve, you're getting the bottom bounding line of the JCL curve, okay? It's not the middle. It's not the most likely JCL 50% result. It's the least likely JCL P50 result. In fact, you can see here, the lower P, when you read the actual value of this point right here where your lower P for cost and schedule intersect, you don't get P50. You get P31. So if you think you're approving your projects at P50, you're not, unless you're using the JCL. Like, to approve a project at P50, you need to know when both cost and schedule converge at that P50 number, and that's this isoquant, all right? So unless you want to live on the extreme edges of your risk model outputs, you need to show that JCL. So that's reason 2. But back to Steve's question. So right now I have a target here also, in addition to just the basic reading of the P50, comparing the JCL to the cumulative frequency results. I also have the ability to set a target. So that target you can set by the way, there is a bug here. So my thanks to those showing at up at the Anaheim conference. So this was last demonstrated in Anaheim at the AACE conference. Safran Risk was kind enough to put on a summit the day after the conference was over. We had a lot of really great, intelligent, thoughtful people there, and one of them pointed out that our nearest neighbor calculation is giving some wonky results here. We know. We're going to fix it. But the point is that it is it's pulling some data. So let's assume that we wanted to get this project done in fiscal year 2033 for a cost of around $1.8 billion. That'll actually tell you what your JCL is for that. So if your estimators and your schedulers had something different than what's been shown on all these other pages, right? Like if you stripped all of their contingencies out, this is an opportunity to put them back in. So we run, because you're supposed to, a stripped adjusted base cost and schedule estimate into the risk model as an input. But now that we're evaluating outputs, we can put those contingencies back in and see that with those contingencies, we're sitting at over 70%. So that's how we can kind of ameliorate some fears and concerns by the estimating team and by the scheduling team in terms of like their estimate showing up at 0%. If you look at the JCL and plug those estimates with their contingencies back in here, there's a pretty good chance that you're not looking at 70%. By the way, this is also something that you can do in Safran Risk. Safran Risk does a very good job of telling this very same story. But again, Safran Risk is proprietary software that must be open to interact with the data model. So, those of you that are Safran Risk users know you have to run the model, run the simulations, and then you can interact with the outputs. And if you close the software or change anything about it, then you have to run the model again and interact with the outputs again. So let me jump back into questions. So higher level, how might we use AI tools and project risk? How could they work together? Well, without revealing too much about our development roadmap, we are thinking about the answer to that question very, very carefully. Something that you may have noticed, you have here on, say, the correlation screen, and in fact, on most screens, you have a narrative. All right, so this narrative was written, in this case, by my good friend and colleague, Roger Bradfield. So he and I collaborated on getting this one pulled together. It is fully anonymized. It's not particularly meaningful, but the point is that we do have a narrative section on each of these screens. Now, the narrative section, eagle-eyed viewers may have noticed that as I was messing with things in the slicer panel, it didn't change anything about the narrative. All right. So even though I've got a nice live data set, the narrative itself is static. Well, those of you who have worked with generative AI and large language models before, you're probably already guessing what we might be able to do with this. Okay. So generating some live narratives that react to the results on the screen is something that we're looking into. On the one hand, that would be a great way to make the tool more adaptive to user inputs and give you even more value on top of the static risk report. But on the other hand, the LLMs unfortunately still do a lot of hallucination. So we need to pretty carefully police this before we release anything to the public. So for now, it's just going to be that. But that's definitely one of the things on our roadmap. Those of you who have used LLMs for risk management before know that it is pretty good at coming up with risks, right? It's not particularly good at estimating those risks, but it's pretty good at least telling you what you might be missing, right? So that's another thing that we might do. We've got the entire risk register in the data model for this tool. We could poll an AI and say, hey, what am I missing? What should I have considered that maybe I didn't? And it could tell you. So those are a couple of things that we're working on. Nothing ready for prime time yet, but stay tuned. Some additional questions here. How can we more clearly explain why most of the time the deterministic data is at P0? So I think I covered that. But if you have a follow-up question or if I didn't answer it to your satisfaction, I hope you'll get back into that Q&A and ask it again. Next one, just to confirm with the exported data set, you basically don't need Safran to update your QRA outputs. Yes, you do. So this is a static set of one risk analysis, right? So if you are following best practice for your risk analyses, then you are periodically updating the inputs into Safran Risk in order to see how those outputs compare to your last set of outputs. You maybe don't have to do a fulsome redo of the model, but you do have to do something, right? Because actuals have occurred, new risks have materialized. Maybe you've got some more on your risk register. Some other ones have come off or become issues. Your project is in a different place 6 months later than it was when you initially ran the model. So you can use this to slice and dice an existing risk model that you've used Safran Risk to generate. What you can't do is update those inputs and then see live outputs. For that, you still need a Monte Carlo simulation engine. And those of you that have gone under the hood on something like Safran Risk or Oracle Primavera Risk Analysis or Acumen Risk or any of the other fully integrated cost and schedule risk simulation things like VOS Project Risk, any of those things, they all have critical path method scheduling engines in them. All right. Power BI does not have a critical path method scheduling engine. So yes, you do still need Safran Risk if you plan to update your inputs. Next question, how about including schedule uncertainty in the schedule analysis for a specific task? Would you say the approach is wrong? It's not wrong. Now, we absolutely do, when we're building our risk models, we include schedule uncertainty in our inputs. It's really important that you do that, by the way, because just like cost, the durations on a schedule are good the moment they're created, and maybe they're not even good then. There is natural variability in how long an activity might take for all kinds of reasons unrelated to your discrete risks. So even if you have done an absolutely perfect job of putting together your risk register, there's still going to be some sources of variability that you did not consider. And in order for those to be part of your risk model, you have to allow your activity durations to range. So it's not wrong to include them by any stretch of the imagination. Now, what I will say is that when you're running a fully integrated cost and schedule model, it's just one ingredient in the stew, right? So schedule uncertainty goes in there with cost uncertainty, goes in there with your risks, goes in there with anything else you've used to condition your risk model, like your correlations, for example. And by the time the results come out, it is an aggregated pool of results. Disaggregating them does not give you better information, unfortunately. Now, having said that, and this is something that our tool cannot replicate in Safran Risk yet, okay? But in Safran Risk, if you run a Monte Carlo simulation on an integrated cost and schedule model, and then go into their scheduling suite, you can see how the model configuration has impacted each individual activity at various confidence intervals. So for now, at least, if you want to see on a per activity basis how the risk model is behaving, the best place to do that is Safran Risk. Okay. So I want to thank Pooja for being a two-question person at this point. So thank you for that. Let's get that. So say at P75, few risk sensitivity analysis shows absolute values in days and cost. Does this value mean the most likely value or the maximum value? So that really depends on your. Okay, it actually doesn't show either. All right. When you are running sensitivities, it means you are running either a single or a multi pass against the risk model. So what that means is you build the risk model, and you've got all the risks in the risk model. And then when you run the sensitivity, you take that risk out and then you run the model again. So on a single pass, which is the easiest one to explain and the one that I understand the most, that's how that works, full stop. So if you run the risk model, 100,000 times or 10,000 times or 5,000 times or whatever, and then you pull a specific risk out, and then you measure the difference between those results, that is your P50 or P75 or whatever result for that one risk. Is like, if you take that risk out, then the model behaves thusly. So that means that you're seeing an amalgamated result from both the cost and schedule inputs, and you're seeing it at specific confidence intervals. One of the nice things about Dokainish project risk is that you do have to have pre-baked the sensitivity, and that's another thing we're getting from Safran Risk to seed the data model. But you don't have to wait for a rerun to do the different confidence intervals. Like if you want to see how a risk does confidence interval stuff, excuse me, if you want to see how a risk responds at different confidence intervals and is impacting the project, you can simply change the slicer and it will show you. And you can even see two at once, as I showed you earlier. So my friend and colleague, Nate Habermeyer, is reminding me that, yes, in fact, we do have a podcast. Okay. We talk about stuff like this. We generally don't get into this much technical detail, but the podcast is a lot of fun. And, we would love to answer more questions like this one on that podcast. So head over to riskyplanner.com, or if you can't remember that, the title of the podcast is The Risky Planner, by the way. I'm all over LinkedIn talking about it. So follow me on LinkedIn, follow Nate on LinkedIn. You'll get all the updates from the podcast. Or you can just head over to Dokainish.com. That's Dokainish.com. And you'll see everything that we're working on as a company, including and especially the Risky Planner podcast. And of course, for future updates to these kinds of webinars and whatnots, Steve's your guy. And here he is. Thanks, Steve. Thanks to you, Steve, and thanks to everybody in the audience. Oh, by the way, I'm going to stick around and answer those questions. Oh, never mind. Hey. Did that worked for you? Thank you.